Hello. Hello.
Hello.
Sir, in RCPSP chart, Y4 is parallel and 3 and 1 are sequential.
Which one parallel?
Task 4 is running parallel to 3 and 1.
What we are saying? I'm not getting.
3 and 1 are running sequentially, but Y4 is running parallel.
Which you know to correlate to the questions. Which question you are asking?
RCPSP Gantt chart.
Oh, Gantt chart one.
Yes, sir.
So I need to tell the context. Otherwise, it will be very difficult. So this one.
RCPSP 9th number.
So what you are telling?
4 is running parallel to 3 and 1.
4 is running parallel to 3 and 1. So in our precedence, we have only 2 to 3. So only 3 need to be run after 2. That is the only thing defined.
But Y3 1 is not running parallel to 3, sir.
It can be run, but this is one example.
But that will reduce time by 1, sir. 1 unit.
Can you produce?
Time will reduce by 1 unit.
If you run 1 and
3 and 4 parallelly.
If you run 1, 3 and 4 all parallelly, then how much resources you require? So if you look at 3, if you run 1, 3 and 4 parallel, then how much resource 1 you require? 5 resources you require. And if you require
okay, sir. Got it.
1, 3 and 4, 1, 2 and 3, 1, 3 and 4 parallel, how many resources do you require?
6.
5, 1, 3 and 4. 10 resources you require. You have only 7. You can.
Okay, sir.
Excuse me, sir.
Yeah.
Sir, in the 12th slide, in single machine problem.
Yeah.
Sir, here R is written 1. Does that mean that the release time of each of the process is 1?
Here R is number of resource type.
Okay, so small r is the number of resource types.
Yeah.
Okay. Thank you, sir.
And sir, I have a doubt on binding.
Yeah. Again, same slide.
Binding side, first or second slide.
Yeah. Binding. Yeah. So what is your doubt?
Like, sir, we are scheduling these ACF for first processor, and are these processor dependent on processor?
No. So in this example, so n taxes all are independent taxes.
And on what basis we are scheduling processor these tasks?
This is one example you are saying.
Okay, sir.
This is not the what you are optimizing, we are not defining, but this is example of binding and example of settling, an example of allocation. So on what basis you are doing one, what you are optimizing also we don't know, but this is one example. Okay.
Okay, sir.
You got my point?
Yes.
Yeah.
Excuse me, sir.
Yeah.
So what is the syllabus for this midterm? Is it after the quiz one or all?
So there will be 2 30-minute repeat exam, and one will be fully means between quiz 1 to mid semester, and another one will be up to mid semester from the beginning.
Okay, sir.
Okay, so let's come back to our tax scheduling part. So this thing already you have sent, and this book is already uploaded to our MS Team HPC group. Okay, and this thing already done. So in parallel machine, we'll mostly focus on three things: P, Q, and R. Okay, so P is for identical machines, and Q is for uniform machines, R is for unrelated machines or completely heterogeneous. Okay, so this thing already you have seen this thing. This is identical. Identical means tasks running on any processor will give execution time will be same, and uniform will be based on the speed. Okay, so task one execution time will be depend on processor, and that execution time will depend on speed of the processor. And third one is completely unrelated, and we can say it is heterogeneous. Okay. So it is heterogeneous. Okay, so unrelated machines. And this thing also last class we have discussed yesterday. So classification of scheduling pattern. So alpha defined, alpha, beta, gammas, what I can say notion. So you can define most of the scheduling problem. You can categorize the scheduling problem based on these three parameters: alpha, beta, and gamma parameter. Alpha specify the machine environment, beta specify the job characteristics, and gamma specify the objective functions. What you want to optimize. So either minimizations or maximizations or whatever you want to, what you want. Okay. So what is your goal to do? Okay. So it don't specify how to do, it specify what to do. Okay. It specify what. Alpha is machine environment. So mainly processor. Okay. Means how many processor, what kind of processor. Beta specify job characteristic, what kind of job. And gamma specify what kind of objective functions or what we want to optimize. So this tell about the problem, not the solution. This is problem. So three field classification: alpha, beta, and gamma. So in alpha, there are 1, P, Q, and R. So 1 means single machines, P means parallel identical machines, Q means uniform machines, R means unrelated machines. And P means identical. P and Q difference is their difference in terms of speed. And P and R. So if whenever we say it's completely unrelated. Okay. And job characteristics. So whenever you say PMTN, okay, so sometimes we say PMTN or PTMN, both are similar kind of thing, but in book we says PMTN, preemptions. Okay, so whenever we say PMTN, then preemption is allowed. Whenever we say preemption, we are not mention anything, means by default preemption is not allowed. Okay, so release time. RJ is release time. At what time task comes to the system? Okay, that is release time. So, and again thing is deadline. So at what time this task need to be finished? Okay, before the time. And job characteristics maybe PJ is equal to 1, PJ is equal to P, and PJ is equal to 1, 2. So restricted processing time or arbitrary processing time. Suppose PJ is equal to 1. So whenever we say PJ is equal to 1 means all jobs have execution time 1. When PJ is equal to P means all job have execution time of P. And whenever I say PJ belongs to 1 and 2 means all execution time of job either 1 unit or 2 unit time. Okay, so and can be if it is not specified by default, we say it is arbitrary. Okay, so whenever we say deadline not specified means by default value is infinite. Okay, no deadline. So release time not specified means by default we assume that all job arrived at time 0. If PMTN is not specified means what we say by default it is preemption is not allowed. Okay, default one. And then dependency can be simple precedence constant, simple entry or chain or series parallel. Okay, so any kind of precedence constant can be. Okay, so let's see what kind of precedence constant. So
In the
yeah.
previous slide,
Yeah.
what was this restricted processing time? Could you explain this part again? No, in the next slide. Beta. Yeah, in here, what is restricted processing time?
Restricted processing time means suppose processing time of each job is it is either unit execution time or fixed execution time, or it is one or two. So unit execution or 2 units. Suppose if job comes with that characteristics. Suppose you have jobs, so that will take either 1 hour or 2 hours. Okay, so either 1 hour or it will take all 10 hours. Okay, so this is suppose all jobs takes 10 hours. Then we say that it is Pj is equal to P. All jobs takes same amount of time but not unit. Okay, Pj is equal to 1 means all job takes 1 hour. So in this way, what I am saying is 1 hour is unit, 1 unit time. Okay, so and Pj belongs to 1 and 2 means all jobs execution time is either 1 hour or 2 hours. Okay, this is restricted. If job statistics come with restrictions. Okay.
Okay, sir.
And whenever I say job statistics, one more thing is also it is coming. So the release time. Whenever we say release time RJ, that means if RJ is not specified, then by default we say it is all jobs arrived at time 0. All jobs arrives at time 0. That means all jobs comes at time 0. If release time is not specified. So here I am trying to explain one more thing also. Let me explain you. So what is the difference between online job and offline job? Have you heard about this term online and offline?
Yes, sir.
So can you explain what is online job and what is offline job?
Sir, usually offline jobs mean processing is done after like when we do not have to entertain requests. So we keep on accumulating requests for the day, and once it is offline, we process all those requests in the night, something like that.
So let me define crisp and clearly. Okay, offline job means you know at what time jobs comes and how much time it will take. Okay, at what time job will come and how much time it will take. That information is available at time 0. That is offline. So and online means once job arrives to the system, then only you will get to know. So at what time arrives and how much time it will take to execute. This is called online. So have you heard about reservations, railway reservations? Hello, I am giving you simple example. Railway reservation. So
yes,
whenever you reserve in railway, so Indian Railway, suppose a train is coming from Delhi to Guwahati. Okay, and all the reserve passengers, we call them as offline passengers. That means for all the reserve passengers, we know which passenger will come at what station and for how much distance it will cover. Means at what station he will get down. We know the information and how many passenger at what station and for each passenger up to how much distance they will travel, that we know. That is called offline one. And online one means so the passenger who don't do the reservations, but they turn up at the time of journey. They come to stations at run time. And once they come, then only you will get to know how much distance they will go and how many number they will come. You got my concept got clear? What is offline tax and online tax? I correlate this to train reservation system. Reserve passenger are the offline one. They may not require to run enter into train at Delhi. All the passengers need to board the train at Delhi. That means all tasks need not to come at time 0. They may have different release time or arrival time, but we know them at what station they are coming, at what time they are coming. Okay, that means if you reserve, then it will come to actually offline category. If it is on reserve, then it is online category. Once the tasks arrive to the system, then only you will get to know about the characteristics of tasks. That is the difference between online and offline. Now this concept got clear?
Yes,
sir.
Yeah. So you correlate to railway reservation system. It will be clear. Reserved passengers, even if they come with release time at what station they will enter, still that is offline. And on-reserve passenger, all on-reserve passengers, so we don't have any informations. Whenever they arrive, then only we'll get to know up to how much distance they will travel. Or in this case, after task comes to the system, then only we'll get to know means what is the execution time or other information about that task. Okay. Next, in the precedence constant means this is first one is independent job. So are you able to see the first set of job? So we have actually 7 jobs, are all are independent jobs. So independent jobs have 0 successor and 0 predecessors. Can I say that thing?
Yes, sir.
Yes, sir.
That's, they don't depend on any others. Okay. So 0 successor and 0 predecessors. Suppose I say every job have maximum of 1 predecessor and 1 successor. Maximum. So it can be 0, but it can have maximum 1 predecessor and 1 successor, not more than that. Then it will be a chain of job. Very simplistic one. Okay. Can I say means in out tree? Okay. So this is what I am saying is in tree. Okay. In tree. So a job have multiple means 1 predecessor, multiple successor. In this case, so multiple successor, 1 predecessors. Okay. So it is somehow it is take this job. It have multiple predecessors. Okay, multiple predecessors, but 1 successor. Okay, so this 1P MS or MS1P, this is actually somehow both are same. Okay, it should be 1P MS or MP1S. It should be, but it's fine. So this is a SP of job. Okay, so series parallel job. This is series parallel job. So this is this is one job. Then there are 2 successor, and then they are merging into one. Then this is serial parallel job. So this is fork and join kind of things. Okay. So this is forking node and this is joining node, and in between there are parallel jobs. This is syncing node. Okay. This is again forking 3 tasks and joining at this. So this is series parallel job. Okay. So series of parallel fork and join, we can say. Okay. And last one is DAG or general precedence constants. So which one is simpler among all?
Independent.
Independent job is simpler. Then you added some kind of what I can say 1S1P. That means every job have at most 1 predecessor and 1 successor. In this case, either predecessor will be 1 or successor will be 1. Suppose this is a entry. Okay, so this is a entry. So in case of entry, so every node have only 1 successor. Every node have 1 successor. Entry. Okay, out means it is just reverse. Okay, and this one is more common, DAG or precedence constant job. And whenever we say means precedence constant, so we don't go for directed graph with cycle. Okay, so DAG means it need to be topologically sortable. Okay, topologically sortable means directed graph. That means by default it will be DAG. What are the objective functions?
Sir?
Yeah.
Sir, in previous slide here, in the case of a tree precedence,
Yeah.
so the condition specified is 1 successor and multiple predecessors, right? But
Yeah.
these conditions are not enough for a tree structure, right? I mean, I can make like using only these conditions, I can make a cycle as well. So, I mean, shouldn't I specify more conditions here?
Can you make a cycle?
Yes, I'll give you an example. Suppose I have a node, and then there are 2 successors, and each of the successors have a common successor in turn. So this will form a diamond kind of structure.
But here in tree also the cycle need to be removed. Okay, so
Yes, we'll have to specify.
no. If you look at whenever you say, so number of edges will be n-1 always. If you have that thing, then you will not get cycle.
Yes, we'll have to specify n-1 edges, and one more thing, the thing has to be connected.
Yeah. So that, not only this, whenever I say this is n-1 edges need to be there.
Okay, sir.
Okay, but in DAG that specification is not there. But no cycle.
Okay, sir.
Done?
Yes, sir.
Okay. And third one is actually objective functions. What do we want to optimize? Okay. So in this case, two type of objective functions are most common. So one is bottleneck objective. Either you calculate maximum or minimum. So function fj cj. So cj is completion time. This is examples bottleneck objective functions. And next one is summation objective functions. Okay, summation of fj cj. So functions f1 c1 plus f2 c2 plus up to fn cn. Cj is completion time of task. This is one examples. Okay, so this max fj cj is one example, and then summation of fj cj. This is one another. But most of the objective functions are this kind. Okay, so either bottleneck functions or some objective functions. Okay, some objective functions or bottleneck objective. Let's give many examples, then it will be more clear. So ultimately, any scheduling problem. So in general, we specify using alpha, beta, gamma format. Okay, and alpha specify the machine, beta specify the job environment, and gamma specify what we optimize. So objective functions gamma. This is another things. Cmax and Lmax symbolize bottleneck objective. Cmax objective function is so with fj cj is equal to cj. So directly fj is directly we say cj, means fj cj is cj, and whenever you say only cmax, then maximum of all cj, that is max 1. Okay, overall execution time. And Lmax objectives, so suppose every task have some deadline. Okay, so this is maximum lateness. Suppose n tasks are there, and on suppose p processor we want to execute, and every task have some deadline. Okay, then Lmax objective is says that maximum of cj minus dj, maximum lateness. Then common sub objective functions are summation of cj, that is mean flow time also, or summation of flow time. Okay, so whenever you say flow time can be means whenever you say flow time. Let me change to my pencil. So cj is a summation of cj. Okay, summation of cj. So cj we say mean flow times. Okay, flow times whenever you say fj, suppose if I say another term fj is equal to cj minus rj. So here flow time is how much time the task has stayed in the system. That is flow time. Okay, so completion time minus release time. And summation of wj cj is weighted flow time. Okay, and for suppose all the tasks arrived at time 0, then what will happen in this case? All the tasks arrived at time 0, then flow time is equal to cj by default. And if you sum it, then you will get actually a total waiting time. Okay, suppose you minimize total waiting time or you minimize average waiting time. So both will be means actually same thing. Suppose you do means minimize, so summation of this thing you do minimize this. It is same as, because whenever you means execute all the tasks, okay, on suppose p processor, then if you optimize, suppose minimize this, minimize summation of cj, which is same as actually minimization of means average waiting time. Suppose every job have waiting time, so you can say Qj plus Pj. So what is the queuing time? Queuing time plus Pj. So this thing same as this one. And anyhow, if you execute all the tasks on the system, then this is same as actually minimization of summation of Qj, queuing time. It is total waiting time. And if you want to minimize the average waiting time, still if you minimize the total waiting time, then it will minimize the average waiting time also. So which can be similar to actually minimization of summation of Qj by n. N is total number of tasks. So if you look at minimization of flow time is same as minimization of sum of actually finish time, which is same as minimization of waiting time, sum of waiting time, and which is same as actually minimization of average waiting time. Is this clear? Last class also we discussed this thing.
Yes, sir.
Okay,
Sir, what is
so
weighted flow
Sir,
time?
even have processes have different release times, still minimizing the flow time is same as minimizing the average completion time.
yeah. Got my point? So another thing is weighted flow time. So suppose every task come with weight. So in that case also, this is the problem statement. How we will do that is different issue. Okay, so this is how we're defining the problem. What only the solution we are not discussing. We are discussing the problem. Okay. This is the common sum objective functions.
And sir,
And
what was DJ?
yeah,
DJ, what is DJ here
what is
in Lmax? DJ in Lmax.
DJ is deadline.
Okay.
Suppose every task comes with deadline. So completion time minus deadline. What will get? Late. Which task got how much late? And if you maximize maximum lateness, suppose you want to minimize the maximum lateness. So many times we want to minimize the maximum lateness.
Okay, so this is overhead in a sense, how much a task got late. Okay.
So many objective functions we define in that way. Minimize the maximum lateness. Okay. And another objective one, suppose every task has come with some deadline. Then this is another thing. Summation of Uj. Whether Uj is equal to what is Uj? So okay. What I'm saying is this Uj equal to 1 if Cj is greater than Dj. If execution time, so completion time is greater than deadline, then Uj is equal to 1. That means it is Uj means unsatisfactory. Okay, for that task. And Uj is equal to 0 if means completion Cj time is less than equal to Dj. Deadline say under ho gaya, so there is no issue. That means unsatisfactory, that Uj is 0 if the task is completed before deadline. And this is natural one. Okay, and some objective function can be summation of Uj, number of late job, or number of weighted late job. Okay, means our summation of Wj Uj, that is a weighted number of late job. This can be another means objective functions. Then another objective function is summation of Tj, summation of tardiness. What is tardiness? All late. Okay, so Tj is equal to max of 0 and Cj minus Dj. So max of Cj minus Dj. So if the job finishes, if Cj Cj minus Dj, Cj minus Dj, if the task completed, suppose completion time is less than deadline, then this term will be, if suppose Cj is less than equal to Dj, less than hota hai. If it is less than, then what will happen? If it is Cj
Tardiness is
Then it will
0.
be negative.
Cj is less
And
than,
tardiness will
it will be
become
negative. If Cj is equal to less than Dj, suppose it is less than, then Cj minus Dj will be a negative term. Okay, maximum of 0 and negative will be 0. Okay, if Cj is greater than Dj, then this term Cj minus Dj will be a positive term. Then only it will be a positive term. In that case, we will consider the positive term. That means lateness. Tardiness and lateness are both the same. So objective functions can be sum of tardiness, so summation of Tj, and weighted sum of tardiness or weighted sum of lateness. Okay. So clearly you can see how many objective functions? The Cmax, Lmax, then some objective functions, summation of Cj, summation of Wj, Cj, then summation of Uj, summation of Wj, Uj, and then summation of Tj and summation of Wj, Tj. So there are 5-6 objective functions. Most of the problem it comes under this. Okay, but we can think of power optimizations or temperature minimizations or energy optimizations, but still that is not considered here. Okay, so we're looking at very high level parameter we are looking at. Is this clear?
yes, sir.
Yeah, hope this is clear. Okay, and next move towards example of scheduling problem. So first problem, what it is doing? Look at the first problem.
Sir, it's saying one processor is present.
So first problem, the system have one processor, and what is this? The tasks are organized in a precedence constant (DAG) form, and all task execution time is 1. And what do we want to optimize?
Weighted completion time.
Weighted completion.
Minimizing the weighted completion time.
Okay. Sir, here the weights should also be given, right?
Weight should be
Like weight should also be mentioned, right?
yeah, weight should be also mentioned in task environment, but by default, whenever we say Wj, Cj, then weight is mentioned.
Okay, sir.
And it is arbitrary weight. Okay. So what is the second problem? Says second problem.
So there
So we
are
have
two
processor.
processors of
So
type
two
P.
processors, and nothing is specified in the middle. That means tasks are arbitrary, no dependency, preemption is not allowed, release time is 0, deadline is infinity. So whenever I say this thing, so by default, so whenever these things, so in this case, Ri release time is 0. Suppose let's write Dj is equal to infinite. Then precedence constant, no precedence. Precedence is independent, so default independent. Okay, and preemption is not mentioned, so no PMTN, no preemptions. So by default, release time is 0, deadline is infinite, no precedence constant, and no preemptions. And what we are optimizing? So we have n taxes. By default, n taxes, 2 processor, and this processor are identical processor. Whenever you say P, it is identical processor, 2 identical processor. And what we are optimizing? What are minimizing? Cmax. What is Cmax? Overall execution time. This is the problem. Okay. Overall execution time. Third case. In this case, what we are doing? In this case, third case.
So there is a single processor.
No, we have P processor. P processor means M processor. By default, M processor, N taxes. All task execution time is 1. All tasks have their release time. All taxes have their release time. Also, whenever we are optimizing summation of Wj, Uj, means all taxes come with deadline. Also, all tasks come with weight.
Release time.
Okay. So here in this case, all taxes have Dj. Okay, and all taxes have release time. also all taxes have weight. All taxes have weight. By default, it means what it indicates that thing. All taxes have deadline, all taxes have release time, all taxes have weight. And what we are minimizing?
Weighted number of
deadline.
Weighted
number
late.
of late jobs.
Late job. Weighted number of late job. Okay. So this one. So this is summation of WJJ, weighted number of late job we are minimizing. Okay. So fourth cases. What is the problem? R2, chain, PTM, and Cmax. So what is R2?
Two unrelated machines.
Unrelated process.
Unrelated processor.
Two unrelated processor. All tasks are arranged in chain fashion. Every task has at max one predecessor and successor. Okay. Release time not mentioned means all tasks arrived at time 0. PMTN mentioned means tasks can be preempted. Tasks can be preempted. PJ not mentioned, it means arbitrary execution time. And what we are minimizing or optimizing? Overall execution time. Okay. So in this way, we classify the scheduling problem. Okay. So R n is equal to 3 Cmax. What it says? Number of tasks is equal to 3. Okay. And if it is precedence constant is not mentioned, by default it is independent job. Release time is 0. Deadline is infinite. Okay. No preemptions. And but number of tasks is only 3. And R is, what is R? Unrelated processor.
Unrelated processor.
Okay. And this one, this should be PJ, not PIJ. This should be PJ. Okay, this should be PJ. So this P means this is n identical processor. PJ is equal to 1, and the tasks are arranged in out tree format, out tree format. Every task has a release time. And what do we want to optimize? Minimize the summation of completion time, or minimize the total flow time. Okay. And this one, what is this Q? Till now I have not uncovered. What is Q?
Uniform processor.
Yeah. Processor with speed difference. Okay. Identical processor with speed difference. Okay. So Q means identical processor with speed difference. Q is uniform processor, and uniform processor means identical processor with speed difference. Okay. So n number of uniform processor, all tasks have execution time 1. Okay. And whenever say TJ means they have deadlines. Okay. So they have deadlines. So here every task has a deadline. Okay. And Ri is equal to 0. Okay. No preemption mentioned means by default means whenever nothing is mentioned means no preemptions. No PMTN. No preemptions. Okay. And what we are optimizing? Summation of lateness or summation of time. So we want to minimize this thing. So any scheduling problem can be mostly we define in this alpha, beta, gamma format. Alpha represents the machine environment, beta represents the task environment, and gamma represents what to optimize. And I am giving you a very, very interesting thing. So if you want to work on algorithmic area of scheduling problem, so we have around 10 million different kind of scheduling problem. $10 million different kind of scheduling problem. So 10 to the power 6 different variety, maybe millions of different variety of scheduling problem we have. Okay, so not a one or two, you can think of million variety of scheduling problem, and many problems that can be solved algorithmically. Many problems are proved to be NP complete. Okay, and many problems we solve using heuristics. Okay, then we'll see. So among this, what are the typical good problems and where we require, we'll see. Okay, and in our whole HPC course, we'll deal with this alpha, beta, gamma notations, always. And we'll try to solve the scheduling problem. First, we'll try to solve using algorithmic approach. If you are not able to solve using proper algorithmic approach, using polynomial time, then we'll go for some approximations. Then if you are not able to do that also, then we'll go for heuristics. So now, can you please tell me what is the difference between exact algorithm, approximations, and heuristic?
Yes, sir.
Algorithm is the most optimal way for something. Heuristics are solving problem by making certain like solving it without proper optimization, just thinking in terms of overall optimization, like how to do like logically something, not perfect optimization.
No, you are not telling properly. So can anyone other can explain this thing? What is the difference between a heuristic and what is the difference between heuristic and a algorithm?
Sir, in approximation, usually we have some factor like the optimal by 2 or optimal by 3. But in heuristics, you just take some concept or some like there is no quantitative.
Yeah, so that is the correct answer. So let me explain you what is the correct answer. Already we have explained, I think so correctly. So given a problem, so suppose you are if solution exists or optimal thing exists, then algorithm will definitely solve the problem and give you the optimal solutions. This is the algorithm. Okay, and it may take polynomial time or may take exponential time. So we are not telling about time. Okay, this is algorithm. Algorithm is definitely it will give the optimal solutions. Okay, and whenever say approximations, your algorithm you are not able to find a solutions. Okay, for the problem, but we are able to solve the problem up to some extent and we quantify the problem how much far from the optimal. Okay, so you have a solution approach, but how much far from the optimal solutions? But it is in polynomial time we are able to do, but how much far if you can prove this, then it is approximations. And third category is you have some solution approach, but you are not able to prove how much far it will be from the optimal solution. That is called heuristic. Heuristic is completely, I am using very typical word called jugaad. Okay, so heuristic is some way of some anuman or sub jugaad. We are not able to prove how much will be far from optimal, but it will give reasonably good solution at reasonably good amount of time. So how much time it will not take? It will take, we don't know. How much far it will be from optimal, that also we don't know. But overall, it will give a good solutions, kind of very good jugaad. That is called heuristic. And if you prove the jugaad, then it will be approximations, or it will be algorithm. So if you can prove that it will give optimal solution, that will be algorithm. Your approach, suppose your solution approach, if you can prove that it will give optimal solution, then it is algorithm. If you are not able to prove, suppose it will give up to quantify that thing, it will be this much far from optimal solution, that will be approximations. And if you are not able to do anything, then it is heuristic. You got my point?
Yes, sir.
Yes, sir.
Okay. So heuristic means you are not able to prove how good it is. Then that is heuristic. Okay. But it may work very nicely. Okay. But how good you are not able to prove. So have you heard about heuristics algorithm, genetic algorithm? Have you heard about genetic algorithm or simulated link and colony optimizations? There are many heuristic, meta heuristics are available, but common heuristic for solving any kind of optimization problem. Okay, so why you call meta heuristic? It is a common heuristic to solve all kind of optimization problem. But we don't know means how much far from the optimal solution, but it will reasonably give a very good solution with reasonable time. Okay, so if you look at many other engineering branches, they just simply use the genetic algorithm or simultaneous link or end colony optimizations or particle swarm optimizations. These are common heuristic or meta heuristic for solving any optimization problem. It will give a good solution at reasonable time, but we cannot prove it because it is heuristics. Okay, if you can prove, then it will be approximation or algorithm. Okay.
Excuse me, sir. If
Yes.
there is no precedence order given, then should we consider the jobs independent? And sir, in the third case, is DJ infinite?
In the third case,
example. The third example.
Third Pj is equal to 1 Rj. In that case.
Yes, sir.
In that case, Dj is not infinite.
Okay, so when the function is, when gamma is depending upon DJ or something like that, we should assume it is given.
It is assumed.
Okay, thank you, sir.
Okay, so this thing yesterday also we have discussed. Okay, I think so. So a problem is called polynomially solvable if it can be solved by a polynomial algorithm. For example, so this examples. So what is this problem? This problem
is
What
one
is the
processor, and
Single
we need to minimize weighted completion time.
So one processor, you have one processor, n taxes, release time is 0, no deadline. Okay, and preemption is also not allowed. Okay, so whenever PMTN is not given, that preemption is not allowed. Okay, so all tasks need to be executed wholly. Preemption is not allowed, and we want to minimize the weighted completion time. We want to minimize the weighted completion time. So this is the problem, and this problem can be solved easily. You have one processor, schedule the job. So what is the approach? Schedule in an ordering of non-decreasing Wj by Pj values. Simply order the jobs by Wj by Pj, and then just schedule one after another, because you are simply sorting, and it will give you the optimal result. Okay, and or sorting complexity is analog n, and it will give the optimal result, because this is one example. Okay, or is there any issue in this?
Sir, I think we can prove by exchange argument.
Yeah, we can prove by exchange argument. There is no issue. Okay, so this is some example. Okay, so this is if is suppose this Wj, suppose Wj equal to 1. This problem 1, then what we are optimizing? One processor, and we are optimizing summation of Cj. This can be here, preemption is not allowed. We were writing, then only it is allowed, otherwise not allowed. And scheduling the job in an ordering of non-decreasing 1 by Pj value. That is 1 by Pj means what? So earlier case Wj by Pj, and in this case what is 1 by Pj value? 1 by Pj value is what is implies? What it implies? 1 by Pj. Pj is processing time.
Increasing burst time. Increasing burst time.
Yeah, increasing burst time, or we say shortest job first. Okay, so whichever job is shorter, we first take that job and executes. And Cj is equal to Qi by Pi. Pi is processing time. So Cj is Ci Qi by Pi, that is waiting time plus processing time. And we know we can prove that within the things SJF is optimal. Okay. With the same exchange argument, we can prove that SJF is always optimal. And this also complexity of analog. Why we are giving this algorithmic flavor? So we are trying to solve the scheduling problem. First, we'll try to solve using algorithmic problem. Algorithmic means we formulate, then try to solve using algorithmic. We were not able to solve, then go for approximation, then we'll go for heuristics. That is the flow. But whenever we are seeing a problem, we try to formulate using this alpha, beta, gamma notations. Okay, whether it is from cloud domain, multiprocessor domain, or cloud domain, or edge domain, or it is in from IoT domain. So this is another problem. So what is this problem? So P problem is P, then Pi is equal to 1, Pi or Pj, whatever the Pj is equal to 1, and then Cmax. What is the problem? There are n taxes, m identical processor, all taxes execution time is 1. All taxes execution time is 1. Preemption is not allowed. Release time is 0. Deadline infinite. So this problem is called polynomial. This problem, can you solve polynomially, optimally?
Yes, sir.
Yes.
Sir, we can divide all processes evenly between all the processors.
Yeah. So because all the taxes are equal execution time, okay, 1 unit execution time, and there are m processor, all are homogeneous processor or identical processor. That is all identical processor. Then you can do page wise, schedule the job page wise. P jobs in one page. What P, not P, this is we can say in this case M is number of processor. M job in one page. And it require n by m pages. So n is number of taxes, m is number of processor. Okay. So what will be the complexity? So order of n. So because n is in general bigger, number of tasks are bigger. So can you correlate this to GPU? GPU scheduler. In 2-3 days back, we have studied GPU.
Yes, sir. We are dividing the tasks into SM, symmetric, streaming multiprocessor.
So GPU is the similar concepts. So all taxes are small taxes, but huge number of taxes, and they have many identical processor, and they use a similar approach. Schedule the jobs, all the means smaller jobs in page wise. Okay, exactly same philosophy they use. GPU use this philosophy. So they have M identical processor and many, that n is 10 to the 6 or 10 to the 8 or many smaller independent taxes. Very small, we can assume unit execution time, and they want to minimize the overall execution time. They can do it page wise scheduling, and it can be done in order and complexity. Is this clear? Is there an issue?
No, sir.
Yeah, there should not be any issues. Okay. So now another problem. What is this problem? P2 Cmax. Are you listening?
Identical processors.
There are two
Yes,
identical.
sir, two identical.
N taxes. What are the execution time? T1, T2, or Tn? We can say P1, P2 up to Pn. So Pj we say execution time many times, but in this case we are saying T1, T2, and Tn. So two processor, and we want to minimize Cmax, overall execution time. How can you do? So ultimately divide the task into two subset, and difference of sum of execution time of both the set is minimized. Minimization of difference, this difference, sum of set 1 minus sum of set 2, whatever the values, whatever you're getting, that need to be minimized. And are you able to correlate to the subset sum problem?
Yes, sir.
So there are n taxes, okay, and two processor. We want to execute this n taxes on two processor such that overall execution need to be minimized. That means if you balance nicely, then execution will be minimized if you properly balance. But here clearly it is mentioned that preemption is not allowed. Okay, preemption is not allowed. You can divide the task into two sets and then execute maybe. Preemption and migrations are not allowed. Are you getting a point? So whenever say preemption is not allowed means by default migration is also not allowed. Whenever I say preemption is not allowed, means it implies migration also not allowed. Okay, and if migration is allowed, whenever I say, then by default preemption is allowed. Okay, is this clear?
Yes, sir.
Yes, sir.
So I am
Sir, migration means breaking the job and sending it to other processor.
yeah. So migration means, so preemption means, so you have a job, you divide the job into multiple pieces and you execute on the same processor at different instant of time. Okay. And migration means the pieces will be executed at different processor. So if you are not dividing, then you cannot migrate. Suppose a task T1, suppose this task T2, suppose this takes T2, T2 have 5 units of execution time. And you divide those 5 into 2 pieces, 3 plus 2 pieces. Okay. And if you divide the tasks into 2 pieces, then these pieces you execute separately and these pieces you execute separately on same processor. Then this is called preemptions. You are not executing the whole tasks T2 5 unit time continuously, but 3 unit time we are executing. After some time we are executing 2 unit time on the same processor. Then it is preemptions. Suppose I say, so this one I want to execute on machine 1 and this one after some time I want to execute on machine 2. That means after you are divided these things, you allowed preemption, then one piece you are migrating to another machines. Unless you break into pieces, you cannot migrate the pieces. Okay. So in that way, if preemption is allowed, then only migration will be possible. Is this clear?
Yes, sir.
Okay. And this problem can be solved using, if you map to the subset sum problem, this problem can be solved. And even if this looks very small problem, okay, this is actually really difficult problem. We don't have exact solutions. We have solutions for what I can say pseudo polynomial solutions for subset sum problem. And if you want, you can refer this book. This is what books? Corman book, chapter 37, section 4. This is exactly they mentioned. This is a pseudo polynomial time solution is exist, not the polynomial. And we can get a 1 plus c approximation. If you want, you can go and see. So in this course, we will not touch the solution approach for common one. Okay, I assume that this is already covered in your algorithm course. This is clear, maybe, or should I explain this subset sum problem again? This may not be necessary because it will be repeated.
No, sir, it was taught earlier.
Yeah, so I am simply correlating the things. Okay, so with this our definitions P2 Cmax, this get mapped to subset sum problem, and we don't require this thing. Okay. Now another problem. So are able to see there is a difference. In this case, what I am writing Pj is equal to 1 and Cmax. Okay. In this case, I wrote P2, and in this case, I wrote PM. What is PM? Earlier case, I wrote P, simple P. So earlier case, I wrote P Cmax. Okay. So in this case, I wrote PM. One more thing I added. PM. M number of processor, but this M is very small. It is not 1, not 2. Because for 2 cases we are writing, for 1 cases we are writing 1. Suppose P2 we are writing, and then 1 we are writing. Okay, so P2 something we are writing, then 1 summation of CJs kind of things. Whenever we are writing 1, that is 1 processor, single processor. Whenever you are writing P2, that is 2 processor. Whenever you are writing PM, this M is smaller number, but not 1, not 2. Maybe it is greater than 3, but not very big number. Okay. So whenever I say PM Cmax, so M processor, M is smaller number, but not 1 or 2. N taxes, and then no preemption is allowed. All tasks arrived at time 0. Okay. Preemption is not allowed. Migration is not allowed. And we want to minimize the maximum execution time, minimize the Cmax. And this problem is, earlier it is 2 subset problem, this is M subset problem. And this is actually, we can map this problem to independent set problem. Okay, and this is strongly NP complete problem in strong sense. Okay, divide the tasks into m subset. Difference of sum of execution time of all the set need to minimize, not to exceed the value k, or this is m. Okay, some values, and this is the problem. So earlier it was 2 set, now it is m sets. And
class.
yeah. So now it is stopping. So in this today class we have defined the problem. From tomorrow class onwards, we'll look at the problem. We'll try to solve some problem. Okay.
Yes, sir.
So not tomorrow classes. Next Tuesday classes.
Sir, I think it would be max in place of min in the last line, because we are minimizing the maximum, so it would be max of all the sets.
Yeah. So this one. This one is minimize max of this thing. Yeah, max of this thing. Minimize max of this thing. Yeah, you are. In the earlier slide also same. And in this case, I put minus sign, so that's fine. Okay. Minimizing the Cmax. Thank you. If you have any questions, now we looked at the problem in theoretical way.
Excuse me, sir. Sir, what if PJ is not specified? Should I assume equal PJ for all of them, or is it general PJ?
No, it is general PJ. If nothing is specified, by default it is general. So that's why I told. So if suppose release time is not specified, by default release time is 0. If deadline is not specified, by default deadline is infinite. But suppose you are optimizing tardiness, or what I can say UI, or user summation of user, then deadline is specified. In that case, you can assume.
Okay, thank you.
Okay, so thank you.